Good morning, children. Welcome back to ICAN Physics. Now in this class, we are going to solve 7.11 and the final problem from the 7th lesson. Let's enjoy the class. So figure shows a series LCR circuit. Okay. So inductor of inductance L, a capacitor of capacitance C, and a resistance of a resistor R connected to a variable frequency of 230 volt AC supply. Okay. So variable frequency of 230 volt, that is ERMS. ERMS equal to 230 volt. Okay. And the inductance of the inductor is 5 Henry. A capacitor of capacitance is 80 microfarad. Now convert the microfarad into farad, 10 to the power minus 6. A resistor of resistance 40 ohm. Calculate the frequency, angular frequency, IRMS, I0, potential drop across each, potential drop across LC. Nearly, you have to calculate all the terms. Okay. So first I want to calculate omega. So omega equal to 1 by square root of LC. Okay. Now 1 by L. So what is the value of L? 5. Into C. C is 80 microfarad. 80 into 10 to the power minus 6. Okay. So 5 8s are 40. 400 into 10 to the power minus 6. So how we can write 400? 20 into 20 into 10 to the power minus 6. So minus 3 into minus 3. Okay. So for instead of 220, you can take 120. So 1 by 20. For instead of 2 10 to the power 3, you can take 1. Now minus 3 goes to the numerator as plus 3. Then 10 to the power 3 divided by 20. So by solving that, you can calculate 50 radian per second is the angular frequency. So what is the formula for angular frequency? Omega equal to 1 by square root of LC. Okay. Then you have to calculate the value of mu, that is frequency. So what is frequency? Mu equal to 1 by or otherwise omega equal to 2 pi mu. So mu equal to omega by 2 pi. So omega by 2 pi. So omega. So what is the value of omega? 50. So 50 divided by 2 pi. So 2 into 3.14. So 2 into 3.14, 6.28. So 50 by 6.28. So you can get 7.76 is the frequency. So many hertz. Okay. So first we calculated the 2. Next, ERMS. So we know that V equal to IR. So we can change. How we can change? ERMS equal to IRMS into R. The multiplication R comes to this as division R. So ERMS by R equal to IRMS. So ERMS. So what is the value of ERMS? 230. Okay. So 230 by R. Okay. R. What is the value of R? Is 40. 40. So 0, 0. Now 5 4s are 20. Remainder 3. So when you put decimal point, it becomes 30. 7 4s are 28. Remainder 2. 5 4s are 20. So this much of IRMS. So IRMS is the current. So its unit is ampere. Okay. So from that we can calculate the value of peak current. Okay. So what is IRMS? IRMS equal to I0 by root 2. The division root 2 comes to this as multiplication. So root 2 times of IRMS equal to I0. So what is the value of root 2? 1.414 into IRMS. So what is the value of IRMS? 5.75. 5.75. So when you multiply, then you can get 8.13 ampere is the peak current. Okay. Next, potential drop across the each. Okay. First, I want to calculate potential drop. Potential drop across the resistor. That is V equal to IR. V equal to IR. So, what is V? V is nothing but ERMS. I is nothing but IRMS into R. So, what is IRMS? IRMS value is 5.75. 5.75 into R. So, what is the value of resistance? 40. 40. Okay. So, for 1 0, you can go for 1 decimal point. 57.5 into 4. So, 5 4s are 20. Remainder 2. So, 7 4s are 28 plus 2, 30. Remainder 3. 5 4s are 20. 20 plus 3, 23. How many decimal point? 1 decimal point. So, 230 volt is the potential drop across the resistor. Okay. So, like that we are going to calculate the potential drop across L. Okay. So, potential drop across L. So, how we can write? V equal to I into R. For L, it becomes XL. V becomes IRMS. So, how we can calculate XL? XL equal to omega L. So, IRMS into omega L is the modified form to calculate the potential drop across the inductor. Okay. Now, what is the value of IRMS? IRMS is 5.75. 5.75 into omega. So, omega value we calculated as 50. Okay. 50 into L. So, what is the value of L? L is 5. Okay. So, when you multiply, then you can got. So, this much of voltage. Okay. Here, the word resonate or resonating frequency is given. So, just close your eyes, then you can write the answer. That is, voltage drop across the capacitor is also same. That is 1437.5. Or otherwise, you can calculate. How we can calculate the value? Okay. So, potential drop across the capacitor. Okay. So, directly I want to modify this formula. That is ERMS equal to IRMS into. Here, XL. Here we can write XC. So, what is XC? XC is 1 by omega C. So, IRMS into 1 by omega C. Okay. IRMS. So, what is the value of IRMS? 5.75. Okay. 5.75 divided by omega. So, omega value is 50. 50 into C. So, what is the value of capacitance? 80 microfarad. To convert the microfarad into farad, so it is multiplied by 10 to the power minus 6. So, 80 into 10 to the power minus 6. So, you can get 1437.5. This much of voltage drop across the capacitor. Okay. So, what about the final one? Potential drop across the LC circuit. So, L and C are in resonating frequency. So, XL equal to XC. So, how we can modify this one? That is potential drop across LC combination. Potential drop across LC combination. That is ERMS. ERMS that is equal to IRMS into that is in resonating frequency. So, XL minus XC. Just compare these two values. So, both are same. Both are in resonating frequency. So that when we cancel, it becomes 0. So 0 into something 0. So potential drop across LC combination is 0 volt. Okay. Do you get it now? Do you have any doubts? No doubt.